The year 1493. Heavy waves crash against the caravel's side, and flashes of lightning tear through the night sky. The ships of Christopher Columbus's second expedition were caught in a violent storm off the shores of the New World. Exhausted sailors, clinging to the rigging, watch in horror as strange bluish lights appear at the mastheads and yardarms. They dance, move as if living creatures, enveloping the ship's rigging in an ethereal glow. "Holy Virgin Mary! Those are the souls of dead sailors!" cries one of the mariners, falling to his knees. Others cross themselves and whisper prayers. Fear grips the crew. Many are convinced these are harbingers of doom. But Admiral Columbus, observing the mysterious luminescence, sees something entirely different in it. In his diary, he would later write that he perceived these lights as a divine sign of the storm's imminent end and the expedition's salvation. And indeed, soon the storm began to subside. What then are these mysterious lights that struck terror into sailors? Modern science provides a clear answer. St. Elmo's fire is a special type of electrical discharge that occurs in the atmosphere under certain conditions. Physicists call this phenomenon a corona discharge. During a severe thunderstorm, a colossal potential difference is created between the clouds and the Earth's surface. The electrical voltage reaches tens and hundreds of thousands of volts. When the electric field strength exceeds a critical value, the air begins to ionize, meaning gas molecules break down into charged particles. It is these particles, colliding with each other, that cause the characteristic glow. But why do the lights appear specifically on ship masts, church spires, or mountaintops? The fact is that pointed objects create a so-called point effect. Around them, the electric field is amplified tenfold. Ship masts, yards, metal spire tips, all these are ideal conductors for the occurrence of a corona discharge. Visually, St. Elmo's fire manifests as a bluish or greenish glow surrounding pointed objects. Sometimes they take the form of flickering flames, oscillating and moving across the surface. Unlike lightning, which is a powerful, short-lived electrical breakdown, St. Elmo's fire can persist for minutes or even hours, as long as suitable atmospheric conditions are maintained. Most often, the phenomenon is observed during or before a thunderstorm, when the atmosphere is saturated with electricity. Cold, humid air and low pressure are particularly favorable for its appearance. Sailors noted that the lights most often occurred after a severe storm or at its very beginning. Today, physicists can reproduce this phenomenon in laboratory conditions using high-voltage equipment. But where did the very name of this enigmatic phenomenon come from? Why was the bluish glow on ship masts associated with the name of a saint? History takes us back to the early Middle Ages, to the shores of the Mediterranean Sea, where a man lived who became a legend among seafarers. Saint Erasmus of Formia, whom sailors affectionately called Elmo, was a bishop in the 3rd century AD. According to tradition, he continued to preach Christianity even during harsh persecutions under Emperor Diocletian. Legends say that during one of his sea voyages, Erasmus encountered a fierce storm. When the situation seemed hopeless, a bright glow appeared on the mast of his ship, and the storm soon subsided. After his death, Erasmus was canonized and became one of the 14 holy helpers, to whom people turned in particularly difficult situations. For Mediterranean sailors, he became their chief celestial patron. That is why, when mysterious lights began to dance on ships, superstitious sailors saw in this a manifestation of their saint's protection. It is interesting that in different maritime cultures of Europe, this phenomenon received various names, although all of them were somehow connected with religious beliefs. In Italy and Spain, it was called, Portuguese sailors spoke of, holy body. English sailors sometimes used the term. The French called the phenomenon another patron of seafarers. In Northern Europe, where Christianity was mixed with pagan beliefs, there were different interpretations. Scandinavian sailors saw in these lights a manifestation of the god Thor, or sea spirits. The Dutch called them, quote, "for." The connection between religious beliefs and the explanation of natural phenomena was characteristic of medieval thinking. In a world where scientific explanations for most natural phenomena were absent, people sought answers in the realm of the divine and supernatural. This was especially true for sailors, whose lives constantly depended on the whims of the elements. For the medieval sailor, the sea was not just a body of water, but an abode of many forces, both benevolent and hostile. Any unusual phenomenon required interpretation within this worldview. The appearance of a strange glow on the masts in the midst of a deadly storm could not remain without a religious explanation. Gradually, St. Elmo's fires entered the maritime folklore of all European peoples. They became part of that special culture that formed on the decks of ships crossing seas and oceans. This culture combined practical knowledge with superstitions, scientific observations with mystical interpretations. When mystery meets danger, the human mind seeks explanations capable of quelling fear. For sailors who plied the seas during the age of great discoveries, St. Elmo's fire became precisely such a phenomenon, an enigmatic occurrence demanding interpretation. And here, opinions diverged radically. In the port taverns of Genoa and Barcelona, Lisbon and Marseille, one could hear utterly contradictory stories about the same phenomenon. For some sailors, the appearance of a bluish glow on the masts was a blessing from heaven, a sign that St. Elmo had taken the ship under his protection. This interpretation prevailed among Spanish and Portuguese seafarers. In their understanding, if the lights appeared during a storm, it meant imminent salvation. The 16th century Italian poet Torquato Tasso wrote in his poem, quote, "Zero, quote, 1, quote." However, in the northern seas, where different traditions held sway, St. Elmo's fire was often perceived as an ominous omen. English sailors frequently saw in them harbingers of misfortune, the souls of fallen comrades come to warn the living of impending disaster. Dutch mariners sometimes interpreted this phenomenon as the mischievous tricks of sea spirits, luring ships onto reefs. The psychological effect of the appearance of St. Elmo's fire was immense. Imagine a ship lost amidst raging waves, a storm threatening to sink the vessel at any moment, the crew exhausted from battling the elements. And suddenly, a strange, inexplicable glow envelops the masts. At such a moment, any unusual phenomenon was perceived with heightened emotionality. Interestingly, the crew's reaction often depended on the captain. If he was an educated man, familiar with the works of natural philosophers, he could calm superstitious sailors by explaining the phenomenon through natural causes. If, however, the captain himself was prone to superstition, panic could engulf the entire ship. The diaries of 17th and 18th century captains contain curious entries about how crews reacted to the appearance of the lights. Some sailors fell to their knees and prayed. Others fell into a stupor. Still others tried to touch the lights, or conversely, avoided looking at them. Superstitions played a huge role in maritime culture. Sailors wore amulets, performed rituals before setting sail, and strictly observed omens. In such a context, St. Elmo's fire was not merely a physical phenomenon, but an important element of maritime folklore, a peculiar bridge between the real and supernatural worlds. The great navigators of the Age of Discovery left us invaluable accounts of encounters with St. Elmo's fire. Their diaries and logbooks contain detailed descriptions of this mysterious phenomenon which accompanied humanity's most famous sea expeditions. Ferdinand Magellan, who led the first circumnavigation of the globe, encountered St. Elmo's fire in 1520 during his crossing of the Atlantic Ocean. Antonio Pigafetta, the expedition's chronicler, left us a vivid description of this event. On a night of the most violent storm, St. Elmo appeared to us in the form of a burning torch. It remained at the top of the mainmast for more than 2 hours, which brought us comfort amidst the tempest. When this blessed light prepared to leave us, it emitted such a bright radiance that we were blinded for a quarter of an hour. Magellan, as an educated Portuguese, perceived this phenomenon with religious awe, but without panic. He explained to the crew that it was a sign of divine protection, which significantly boosted the morale of the exhausted sailors. Vasco da Gama, who discovered the sea route to India, also repeatedly observed St. Elmo's fire. In his logbook from 1497, there is an entry. Interestingly, da Gama, being a deeply religious man, nevertheless noted that the phenomenon most often occurs in certain weather conditions. A completely different reaction can be found in the records of James Cook, the 18th century British explorer. In his journal from 1773, he writes, "Cook's records reflect a new, scientific approach to the phenomenon. As a man of the Enlightenment, he sought to find a rational explanation for what was previously considered supernatural. His crew, however, continued to adhere to traditional superstitions. William Bligh, the infamous captain of the Bounty, described St. Elmo's fire as, quote, "4." His rational approach contrasted with the crew's reaction, many members of whom saw the lights as a premonition of the future mutiny. Comparing the records of captains from different eras, one can trace the evolution of the perception of the phenomenon, from a purely religious interpretation among navigators of the 15th and 16th centuries to a scientific explanation among captains of the 18th century. At the same time, the reaction of ordinary sailors changed much more slowly. Superstitions and traditional beliefs persisted in the maritime environment for centuries. World literature has become a mirror, reflecting the enigmatic phenomenon of St. Elmo's fire, transforming it from a nautical superstition into a powerful artistic symbol. The greatest maritime writers have captured these mystical lights on the pages of their works, imbuing them with profound symbolic meaning. Herman Melville, in his monumental novel, created one of the most memorable literary images of St. Elmo's fire. In chapter 39, he describes how, during a nocturnal thunderstorm, the masts of the whaling ship Pequod are engulfed in spectral flames. White, pale flames played on the 3 masts, and at each yardarm flickered 3 thin tongues of fire like sharp, luminous spears. For Melville, these lights become a premonition of the ship's tragic fate and a metaphor for divine presence in the world. Joseph Conrad, a former sailor himself, uses St. Elmo's fire in his novella Typhoon as a symbol of the boundary between the rational and irrational worlds. When Captain McWhirr's ship enters the eye of a typhoon, a ghostly glow appears on the masts. Conrad masterfully demonstrates the contrast between the crew's superstitious terror and the captain's stoic calm, for whom it is merely an atmospheric phenomenon. Edgar Allan Poe, a master of Gothic narrative, transforms St. Elmo's fire into harbingers of the otherworldly in his short story Ms. Found in a Bottle. When ghostly lights erupt on the masts of the doomed ship, it signifies the vessel's passage from the world of the living into the realm of the dead. It is interesting to trace how the perception of the phenomenon changed in literature across different eras. While in 17th and 18th century works, St. Elmo's fire was most often depicted as a divine omen or a devilish trick. In 19th century literature, it acquired a more complex, multifaceted meaning. The Romantics saw in these lights a manifestation of the sublime, a symbol of humanity's mysterious connection with nature. For the naturalists of the late 19th century, the lights became an object of scientific interest, though they still retained their aesthetic appeal. Jack London, in his Sea Stories, describes St. Elmo's fire from the perspective of someone familiar with the scientific explanation, yet still capable of admiring the beauty of the natural phenomenon. In the 20th century, St. Elmo's fire became part of literary tradition, a kind of cultural code referencing maritime mythology. They appear in the works of Ernest Hemingway, William Golding, Gabriel Garcia Marquez, as symbols connecting the material world with the spiritual, science with mysticism, the rational with the irrational. Saint Elmo's fire is not exclusively a maritime phenomenon. For centuries, people have observed similar glows on land, where it evoked no less superstitious awe than it did among sailors. Mountain peaks, tall church spires, castle towers, all these objects rising above the earth became sites for the appearance of the mysterious glow. The Alps have witnessed such phenomena since ancient times. Swiss chronicles from the 16th century describe instances where a bluish glow appeared on mountain peaks during thunderstorms. Local inhabitants believed these were the souls of sinners, condemned to wander between heaven and earth. Mountain guides treated this phenomenon with particular superstition and refused to continue their ascent if they noticed such a glow. Julius Caesar Scaliger, a 16th-century Italian scholar, described in his works an instance when, during a thunderstorm, the spears of Roman legionaries began to glow with a bluish light. This phenomenon was perceived as a favorable omen before battle and significantly boosted the soldiers' morale. In medieval European cities, cathedral spires frequently became the site of St. Elmo's fire. This was especially often observed in Gothic cathedrals, with their sharply pointed spires reaching skyward. Records from the Cologne Cathedral preserve accounts of how, during a severe thunderstorm in 1487, the tops of both towers were enveloped in a strange glow that lasted for several hours. The townspeople perceived this as a divine sign. Strasbourg Cathedral, whose spire reaches 142 meters, is also famous for frequent appearances of this phenomenon. Local legends tell that when a glow appears on the spire, it means the soul of a recently deceased townsman has found its way to heaven. With the advent of lightning rods in the 18th century, following Benjamin Franklin's experiments, observations of St. Elmo's fire on land became more frequent. Metal rods installed on tall buildings created ideal conditions for the occurrence of a corona discharge. In urban chronicles of that time, one can find numerous mentions of strange glows on lightning rods during thunderstorms. It is interesting to compare the interpretations of the same phenomenon by maritime and terrestrial observers. While for sailors, St. Elmo's fire was most often associated with the patronage of saints or the souls of fallen comrades, on land, explanations were more diverse. In the mountain villages of the Alps and Pyrenees, it was believed that these were fairies or mountain spirits appearing during thunderstorms. In cities of Central Europe, a common belief was that the lights were the souls of the righteous, temporarily descending from heaven. In some regions of France, it was thought that the appearance of lights on a church spire foretold the death of a priest. The scientific explanation for the phenomenon on land and at sea is the same. It is a corona discharge. However, cultural interpretations differed depending on local traditions and beliefs. Sailors, whose lives were constantly in danger, saw in the lights a direct connection to their professional fate. Land dwellers, especially urban residents, perceived this phenomenon in a broader religious or mystical context. By the 19th century, with the spread of scientific knowledge, superstitious fear of St. Elmo's fire began to give way to scientific curiosity. Alpinists specifically noted instances of observing this phenomenon in their diaries, describing weather conditions and the characteristics of the glow. These records became valuable material for scientists studying atmospheric electricity. The path of scientific understanding of St. Elmo's fire began long before modern physics. As early as the 4th century BC, Aristotle, in his work, quote, attempted to explain the strange glow on ship masts. The ancient Greek philosopher considered this phenomenon a special kind of aerial fire, arising from the mixing of, quote, one with moist air. Although his explanation was far from the truth, the very attempt to find a natural cause for the phenomenon deserves respect. In the Middle Ages, the scientific study of St. Elmo's fire practically ceased. Religious and mystical interpretations of the phenomenon predominated. Only in the Renaissance did natural philosophers again turn to this phenomenon. Girolamo Cardano, in the 16th century, suggested a connection between the lights and atmospheric phenomena, although he could not explain the mechanism of their occurrence. A real breakthrough occurred in the 18th century when scientists began to experiment with electricity. Benjamin Franklin, known for his kite experiments during thunderstorms, was the first to establish the electrical nature of St. Elmo's fire. In a letter to the Royal Society in 1753, he wrote, "Franklin's experiments with lightning rods confirmed his theory. He noticed that metal rods with pointed ends often began to glow with a bluish light during thunderstorms. This observation allowed him to draw a parallel between laboratory electrical discharges and the natural phenomenon of St. Elmo's fire." Georg Christoph Lichtenberg, an 18th-century German physicist, continued Franklin's research. He created a device that allowed observing electrical discharges in rarefied air and noticed their similarity to St. Elmo's fire. Lichtenberg was the first to describe the special figures formed during an electrical discharge on the surface of an insulator, which are now called, quote, three, quote. By the beginning of the 19th century, the electrical nature of St. Elmo's fire was definitively proven. Michael Faraday, in his experimental researches in electricity, described in detail the mechanism of corona discharge and linked it to St. Elmo's fire. He explained why the glow occurs precisely on pointed objects, due to the concentration of the electric field at the tip. The 20th century brought new understanding of the phenomenon. With the development of quantum physics, scientists were able to explain the bluish color of St. Elmo's fire. It turned out to be associated with the emission of excited nitrogen and oxygen atoms in the air. When electrons, accelerated by an electric field, collide with air molecules, they enter an excited state, and then, returning to their normal state, emit photons of a characteristic color. Modern physics defines St. Elmo's fire as a special type of corona discharge, a self-sustaining electrical discharge that occurs in a gas at atmospheric pressure near electrodes with a small radius of curvature. The electric field strength near the surface of such electrodes reaches a critical value necessary for the ionization of the surrounding air. Today, we can precisely specify the conditions required for this phenomenon to occur. The potential difference between clouds and the ground must be tens and hundreds of thousands of volts. and the electric field strength near pointed objects must exceed 3 million volts per meter. Despite a complete scientific explanation, St. Elmo's fire continues to fascinate not only sailors, but also scientists. This phenomenon reminds us of the long journey humanity has taken from superstitious fear of the inexplicable to a scientific understanding of the world. From Aristotle to modern physicists, the history of studying St. Elmo's fire reflects the evolution of human thought and the tireless desire to unravel the mysteries of nature. The era of the wooden fleet was the golden age of St. Elmo's fire observations. The tall, skyward-reaching masts of sailing ships created ideal conditions for the appearance of the mysterious glow. Ships of that time were true lightning rods in the middle of the ocean. Their wooden masts, saturated with salt and moisture, became semiconductors, and the numerous metal parts of the rigging amplified the effect. A typical ship of the line in the 17th and 18th centuries had 3 or 4 masts up to 50 meters high. On each mast, yards with sharp metal tips were attached, and flagpoles and lightning rods were installed at the top. This entire forest of vertical structures reaching into the sky created many points where the electric field concentrated especially strongly. Sailors of that time noted that St. Elmo's fire most often appeared at the highest points of the ship, on the mainmast truck, on weather vanes, and on the tips of the yards. The glow could move along the rigging, descending and ascending the shrouds, wrapping around blocks and tops. In particularly intense electric fields, the lights could encompass the entire ship, creating a phantasmagoric picture of a glowing, ghostly vessel. The climatic conditions of sea routes also contributed to frequent observations of the phenomenon. The Atlantic Ocean, especially in the tropics and in the Bay of Biscay, was famous for its sudden thunderstorms and storms. Ships plying between Europe and the colonies in America regularly entered zones of increased atmospheric electrical activity. The Mediterranean Sea, with its special microclimate and frequent winter thunderstorms, was also a place of numerous observations of St. Elmo's fire. Venetian and Genoese sailors considered these waters particularly, quote, in the appearance of the mysterious glow. It is no coincidence that many legends and beliefs associated with this phenomenon were born here. The reactions of crews to the appearance of St. Elmo's fire varied significantly depending on the ship's nationality. On Spanish galleons, where Catholic traditions were especially strong, the appearance of the lights was met with prayers and gratitude to the patron saint. Captains often ordered the ship's bell to be rung, gathering the crew for communal prayer. Portuguese sailors, upon seeing the lights, usually removed their hats as a sign of respect and recited Ave Maria. There was a belief that if the prayer was said before the lights disappeared, the voyage would be successful. On some ships, there was even a custom to leave small offerings on the mast, coins or ribbons, in gratitude to the saint. On English ships, the attitude towards the lights was more wary. British sailors, especially in the 16th and 17th centuries, often associated the appearance of the glow with the presence of ghosts or evil spirits. There was a belief that if the fire appeared on the lower parts of the ship, it was a bad omen, foretelling a shipwreck. However, if the lights danced on the mastheads, it was considered a more favorable sign. Dutch sailors, known for their pragmatism, treated St. Elmo's fire more practically. In the ship's logs of 17th-century Dutch captains, one can find records that the appearance of the lights often coincided with a change in weather. Experienced skippers used this phenomenon as an additional meteorological indicator, adjusting the ship's course in anticipation of an approaching storm or its end. On Russian ships of the Petrine era, the lights were called quote 2 or quote 3. Russian sailors believed that these were the souls of deceased comrades coming to warn the living of danger. There was a custom to pour a shot of vodka into the sea upon seeing the lights, as an offering to the spirits of the sea. Interestingly, on ships of different countries, there were strict taboos associated with St. Elmo's fire. On many vessels, it was considered bad luck to point at the lights with a finger or to loudly discuss their appearance. Some captains forbade the crew from looking at the lights for too long, fearing that sailors might fall into a trance or be enchanted. By the end of the age of sail, in the 19th century, attitudes towards the lights began to change. The spread of scientific knowledge gradually displaced superstitions. Captains, educated in naval academies, explained the electrical nature of the phenomenon to the crew. However, even at this time, many ordinary sailors continued to adhere to traditional beliefs passed down from generation to generation. When humanity ascended into the sky, St. Elmo's fire followed it into a new element. World War I, a period of rapid aviation development, gave the world the first systematic observations of this phenomenon by pilots. Aviators, climbing in primitive biplanes through thunderclouds, encountered the mysterious glow that enveloped the wings and propellers of their machines. British ace pilot Albert Ball described in his diaries in 1916, American pilot Eddie Rickenbacker also mentioned encounters with St. Elmo's fire in his memoirs. When you're flying in a thunderstorm at an altitude of 4,000 meters and blue fire suddenly starts dancing around the cockpit, you involuntarily recall all the prayers you know. But the most surprising thing is the sound. A quiet crackling and hissing that can be heard even through the roar of the engine. It was aviators who first noted the auditory accompaniment of the phenomenon. In maritime conditions, the noise of waves and wind often drowned out the subtle crackling of electrical discharges. But in the relative quiet of the aircraft cockpit, this sound was clearly discernible. With the development of civil aviation in the 20s and 30s of the 20th century, observations became more systematic. Pilots of transatlantic flights regularly reported encounters with St. Elmo's fire. Unlike sailors of the past, aviators approached the phenomenon with scientific interest, though not without a superstitious awe. World War II brought a new wave of observations. Bomber crews flying at high altitudes frequently encountered this phenomenon. Navigator of a British .2 bomber, James Watson, left a detailed description. Quote, 3. Comparing aviation observations with classical maritime ones, scientists found a number of interesting differences. At high altitudes, St. Elmo's fire often had a more greenish tint due to the rarefied air. Moreover, in conditions of low pressure and temperature, the glow could cover a much larger surface area of the aircraft. Pilots' observations allowed scientists to refine the physical model of the phenomenon. It turned out that the intensity of the glow directly depends not only on the electric field strength, but also on air density. At high altitudes, less electrical voltage is required for a corona discharge to occur. Modern passenger aircraft, equipped with special static dischargers and flying at altitudes up to 12 kilometers, also regularly witness this phenomenon. Airliner pilots report that St. Elmo's fire is most often observed on the radome, wingtips, and turbine blades. The electrical phenomena of the atmosphere are diverse, and St. Elmo's fire is just one of them. Science identifies a whole group of related phenomena associated with atmospheric electricity, among which ball lightning and sprites hold a special place. Although all of them are electrical in nature, their physical mechanisms and external manifestations differ significantly. Ball lightning is perhaps the most mysterious of atmospheric electrical phenomena. Unlike St. Elmo's fire, which is tethered to pointed objects, Ball lightning is a luminous sphere, ranging from a few centimeters to a meter in diameter, moving freely in space. Its color varies from bright red to bluish, and its lifespan can reach several minutes, incredibly long compared to ordinary linear lightning. In the 19th century, the French astronomer and physicist François Arago collected over 200 accounts of ball lightning observations, but the scientific explanation for the phenomenon is still debated. Modern theories suggest that ball lightning could be a plasmoid, a clot of ionized gas held together by its own magnetic field, or a complex chemical reaction occurring in the atmosphere after an ordinary lightning strike. While St. Elmo's fire is safe for humans, ball lightning is potentially dangerous. There are known cases where it has caused fires, damaged electrical equipment, and even resulted in human injuries. The Russian physicist Georgy Babat, who researched this phenomenon in the mid-20th century, collected numerous testimonies about the destructive consequences of encounters with ball lightning. Another astonishing atmospheric phenomenon is sprites, which were discovered only at the end of the 20th century. These giant electrical discharges occur high above thunderclouds at an altitude of 50 to 90 kilometers in the mesosphere and lower thermosphere. Visually, sprites resemble giant reddish jellyfish or branching trees, extending tens of kilometers upwards. The first scientifically confirmed photograph of a sprite was taken only in 1989 by scientists at the University of Minnesota. It's astonishing that a phenomenon that has always existed remained unnoticed by science for so long. The reason is simple. Sprites last for fractions of a second and are usually hidden from the observer by thunderclouds. What are the similarities and differences between these three atmospheric phenomena? All of them are electrical in nature and are associated with the ionization of air, but their mechanisms of origin are different. Elmo's fire is a corona discharge that occurs when the electric field strength is high near pointed objects. Ball lightning is likely formed as a result of a special type of electrical discharge that creates a stable plasma structure. Sprites, on the other hand, arise as a reaction of the upper layers of the atmosphere to powerful lightning discharges in the troposphere. They also differ in their places of appearance. St. Elmo's fire is observed on pointed objects, ship masts, building spires, mountain peaks. Ball lightning can occur almost anywhere, often entering premises through open windows or chimneys. Sprites, however, are an exclusively high-altitude phenomenon, inaccessible for ground observation without special equipment. The duration of these phenomena also varies. St. Elmo's fire can persist for hours, as long as suitable atmospheric conditions exist. Ball lightning lives from a few seconds to several minutes. Sprites are the most fleeting, their duration measured in milliseconds. Modern science continues to investigate these mysterious phenomena. High-altitude aircraft, spacecraft, and special high-speed cameras are used to study sprites. Attempts are made to recreate ball lightning in laboratory conditions, though with limited success so far. St. Elmo's fire, the most studied of the three phenomena, serves as a model for understanding more complex atmospheric electrical phenomena. All these phenomena remind us that Earth's atmosphere is not just an air envelope, but a complex electrical system constantly interacting with space, the planet's surface, and living organisms. Studying atmospheric electricity allows us to better understand climate processes, predict dangerous meteorological phenomena, and perhaps, in the future, harness atmospheric energy for practical purposes. St. Elmo's fire, like many atmospheric phenomena, has its own geography. areas where it can be observed most frequently. If all documented cases of this mysterious glow were plotted on a world map, an interesting pattern would emerge. The phenomenon is not evenly distributed across the globe, but concentrates in certain regions. The Mediterranean has been considered a true, quote, zero for St. Elmo's fire since ancient times. It is particularly often observed in the western part of this sea, off the coasts of Spain, France, and Italy. It is not surprising that the very name of the phenomenon associated with St. Erasmus originated here. The climatic features of the region create ideal conditions for the occurrence of corona discharges. A warm sea, sharp temperature fluctuations, frequent winter thunderstorms, and strong winds. Another area of increased activity is the Bay of Biscay and the eastern part of the Atlantic. Sailors crossing these waters, especially in the autumn-winter period, regularly report observing the mysterious glow on masts. Here, cold air masses coming from the north meet warm currents, creating powerful thunder fronts. Surprisingly, St. Elmo's fire has its, quote, one sea routes. One of them is the route from the Strait of Gibraltar to the Canary Islands. Portuguese and Spanish sailors of the 15th and 16th centuries left dozens of testimonies about regular observations of the phenomenon in this area. Columbus repeatedly recorded the appearance of the fires precisely in these waters during his expeditions. The second area of high concentration is the South China Sea, especially during typhoon season. The powerful atmospheric fronts characteristic of this region create colossal electrical fields. Chinese and Japanese fishermen have observed the mysterious glow for centuries, calling it, quote, two. On land, St. Elmo's fire is most often observed in mountainous regions. The Alps, Pyrenees, Caucasus, and Himalayas are favorite places for the phenomenon to appear. The sharp peaks of mountains protruding into the atmosphere create ideal conditions for the occurrence of corona discharges. Mountaineers, especially, often report observing the fires on the metal parts of their equipment: ice axes, carabiners, hooks. If meteorological data is analyzed, a clear correlation can be identified between the appearance of St. Elmo's fire and certain atmospheric conditions. The first and main condition is increased electrical activity in the atmosphere. This is usually associated with thunder fronts, although the phenomenon itself can be observed both directly during a thunderstorm and several hours before or after it. The second condition is sharp changes in atmospheric pressure. Meteorologists note that St. Elmo's fire often appears during periods of rapid barometric pressure drop, which is characteristic of approaching cyclones. The third condition is high air humidity. A humid atmosphere conducts electricity better, which contributes to the occurrence of corona discharges. This is why the phenomenon is more often observed over the sea or in the mountains during fog. In the folklore of various peoples around the world, the mysterious glow at the tops of masts and other high points has received numerous interpretations, reflecting cultural peculiarities, beliefs, and fears. These myths and legends represent an astonishing mosaic of human imagination, attempting to explain the same natural phenomenon. Scandinavian seafarers, fearlessly navigating the cold northern seas, saw the St. Elmo's fires as a manifestation of divine powers. In Norwegian sagas, the mysterious glow was called, quote, zero. It was believed that the god of thunder thus showed sailors a safe path through the storm. The Vikings believed that if bluish lights appeared on the mast during a storm, it meant that the Valkyries, celestial warrior maidens, were watching over the ship and were ready to take the souls of worthy warriors in case of a shipwreck. In Greek myths, The lights were associated with the Dioscuri, the twin brothers Castor and Pollux, sons of Zeus. According to legends, they patronized sailors and appeared as two small lights on the masts of ships, foreshadowing the end of a storm. If only one light appeared, it was considered a bad omen. Interestingly, this tradition also passed into Roman culture, where the brothers were called Castor and Pollux, but the essence of the belief remained the same. In Asian maritime cultures, there were their own interpretations. Chinese navigators called St. Elmo's fires dragon's breath. According to their beliefs, sea dragons living in the depths of the ocean rose to the surface during storms, and their breath, touching the ship, created the mysterious glow. Unlike European traditions, the Chinese often saw this phenomenon as a warning of danger. It was believed that dragons thus marked the ship for subsequent destruction. Japanese fishermen believed that the lights were the souls of drowned sailors trying to warn the living of danger. In Japanese folklore, there is the concept of ine no hi, rice lights, which referred not only to St. Elmo's fires, but also to similar glows over rice fields. It was believed that these were the spirits of ancestors coming to bless the harvest. Polynesian navigators, whose navigational culture was one of the most developed in the ancient world, interpreted the lights as a manifestation of the god Tangaroa, the lord of the ocean. The appearance of the glow on a canoe was considered a sign of divine favor and a guarantee of a successful voyage. In Maori mythology, there were special rituals of thanksgiving performed after observing the lights. Arab seafarers of the Middle Ages called this phenomenon, quote, "for." In their tradition, the lights were considered a manifestation of divine presence and protection. Arab navigational treatises contain mentions that the appearance of lights on a ship is a sign that the crew's prayers have been heard. Surprisingly, despite the diversity of cultural interpretations, several universal motifs can be identified in the folklore of different peoples. The first is the connection of the lights with divine or supernatural forces. In almost all cultures, the phenomenon was considered a manifestation of something beyond the ordinary world. The second universal motif is the ambivalence of the sign. In most cultures, there were contradictory interpretations. The lights could be both a good and a bad omen, depending on the circumstances of their appearance, the number of lights, their location, and behavior. The third motif is the connection of the lights with the souls of the deceased. From Northern Europe to Japan, there is a widespread belief that the mysterious glow is a manifestation of the souls of deceased sailors trying to communicate with the living. Anthropologists note that such universality of interpretations is not accidental. The human mind, when faced with inexplicable phenomena in a dangerous situation, strives to structure chaos, to find meaning and regularity in it. St. Elmo's fires, appearing at the moment of maximum danger during a storm, required an explanation that would help sailors cope with the fear of the elements. In an era when photography was just emerging, St. Elmo's fire remained an elusive phenomenon, existing only in diary entries and oral testimonies. The first attempts to capture this mysterious glow date back to the mid-19th century, when daguerreotypes and calotypes already allowed for the recording of static images but required long exposures. This created insurmountable difficulties for photographing such a dynamic and often fleeting phenomenon as St. Elmo's fire. One of the first documented instances of photographic recording of the phenomenon occurred in 1870, when the French photographer Étienne Jules Marais attempted to capture the glow on the spire of Notre Dame Cathedral during a severe thunderstorm. The resulting image was blurry, but still allowed for the discernment of the characteristic bluish glow around the metal cross. Skeptics immediately claimed possible defects in the photographic plate or accidental light effects. By the beginning of the 20th century, with the advent of more advanced cameras and light-sensitive materials, the number of photographs of St. Elmo's fire increased. Particularly valuable were shots taken on naval ships of various countries. Naval sailors, who had received basic scientific education, sought to document the unusual phenomenon, accompanying the photographs with detailed descriptions of meteorological conditions. One of the most famous early photographs was a shot taken aboard the British cruiser "Zero" in 1912 off the coast of Gibraltar. The photograph clearly shows a bluish glow enveloping the radio antennas and mast tops of the ship. The authenticity of the shot is confirmed by the ship's logbook, which meticulously describes the weather conditions and the nature of the glow. With the development of aviation, new opportunities for photographic recording of the phenomenon emerged. Pilots flying at high altitudes, where St. Elmo's fire is more frequently observed, took photographs of the glow on the wings and propellers of their aircraft. Many such shots were taken during World War II by bomber crews. However, the quality of most of these photographs left much to be desired due to difficult shooting conditions. A real breakthrough occurred with the advent of video cameras. In 1968, American meteorologist Bernard Vonnegut first filmed the process of formation and development of St. Elmo's fire on a specially constructed metal rod during a thunderstorm. This video became the first scientifically documented visual evidence of the phenomenon and marked the beginning of systematic study of its dynamic characteristics. St. Elmo's fire, an astonishing phenomenon that continues to balance on the fine line between scientific explanation and romantic perception. Modern physics has fully revealed the nature of this phenomenon, thoroughly explaining the mechanism of corona discharge and the conditions of its occurrence. We know that these are merely electrical discharges in the atmosphere, appearing under certain weather conditions. And yet, when these ghostly bluish lights flare up on a ship's mast or an airplane's wing on a stormy night, even the most rational person experiences awe and reverence. Herein lies the amazing duality of the phenomenon. Knowing the scientific explanation, we cannot help but admire its beauty and mystery. Just as a rainbow does not lose its charm because we understand the principle of light refraction in water droplets, St. Elmo's fire continues to ignite the imagination even of those who know about the physics of atmospheric electricity. In the 21st century, the attitude towards St. Elmo's fire has changed. If previously they evoked superstitious dread or religious reverence, today they inspire aesthetic admiration and scientific curiosity. Modern sailors, seeing the mysterious glow on the masts, are more likely to pull out cameras than to say prayers. Pilots, observing the bluish luminescence on the wings of their liners, make entries in their logbooks, recording meteorological conditions. However, the cultural significance of the phenomenon has not disappeared. St. Elmo's fire continues to live in maritime folklore, literature, and cinema. They have become part of our cultural code, a symbol of the romance of sea voyages, a metaphor for the mystery and unknowability of the world. In an era when almost all corners of the planet have been explored and mapped, when satellite systems track the movement of every ship, when weather forecasts are compiled with the help of supercomputers, St. Elmo's fire reminds us of a time when the sea was full of mysteries and dangers. For modern sailors, this phenomenon has become a peculiar connection to the past, to centuries-old traditions of navigation. Captains of cruise liners and cargo ships tell passengers and young crew members stories about St. Elmo's fire, passing on the relay of sea legends to new generations. In some fleets, rituals associated with the appearance of the lights are preserved, no longer as a superstition, but as a tribute to maritime traditions. The phenomenon of St. Elmo's fire serves as an excellent illustration of the evolution of human knowledge. Using one phenomenon as an example, we can trace the entire path humanity has taken in its understanding of the world, from mythological thinking through religious to scientific. Initially, people saw in the lights a manifestation of supernatural forces or the souls of the departed. Then, with the spread of monotheistic religions, they interpreted them as a sign of divine presence. Finally, with the development of science, they came to understand the physical nature of the phenomenon. This path was not straightforward or unambiguous. Scientific and mythological worldviews coexisted for a long time. Even today, when the physics of corona discharge has been thoroughly studied, many people continue to see something more than just atmospheric electricity in St. Elmo's fire. And there is no contradiction in this, for a scientific explanation does not negate aesthetic and emotional perception. Perhaps this is the main value of St. Elmo's fire for modern culture. They remind us that the world can be both rationally understood and emotionally perceived, that a scientific explanation does not deprive a phenomenon of beauty and mystery. In an era of technology and information, we especially need such reminders. St. Elmo's fire is a bridge between the past and the present, between science and romance, between knowledge and admiration. They continue to shine on the masts of ships and the wings of airplanes, connecting us with thousands of navigators and travelers who for centuries have watched with awe this amazing dance of blue lights in the night sky.